Hi everyone, Kush this side. Welcome back to my channel DevOps Cloud Easy Learning. So this is our session 3 of Docker 101. What are we going to do today? So in the last session, what did we do? We basically went through the Docker architecture. We saw the key instructions of Docker file. And then we also did demo around each one of these, right? We went through a Docker file with all the key instructions. We went through two specific instructions in depth to understand the subtle nuances and differences amongst them. Let me know in comment section what were those two instructions specifically. Okay, it'll be fun. And what are we gonna do today? So we went through the architecture. We went through what is Docker. We did a couple of Docker files, and then we build images, we ran containers, and doing all this was through CLIs, right? Command line interfaces, through these commands. When we went through Docker architecture, we also mentioned that Docker client communicates to Docker daemon. Client talks to the host in the form of Docker CLIs, which sends in the background REST API requests to the Docker daemon, which then entertains and addresses those requests, be it building your image, running your container, networking, volumes, etc. Right? So these CLIs basically are the means of communication between the client and the server. So what we will do today, it's basically a cheat sheet of all the important key Docker CLI commands. So we will go through each one of them and we'll run them. We will see what it does and understand, how it works, so that next time when you all do it, you know which command to use and what should be the expected output out of it. So it is today a cheat sheet or a cheat code tutorial, whatever you want to call it, and we'll get going. With that being said, let's get started. Alrighty. So what I have over here is the repo, which is already shared in video number 2. So please check out video tutorial 2, because I always mention that I link in the description all the references of artifacts, documentation, repos that I use, right? So this is the GitHub public repository of our previous tutorial, as well as today what we're going to do is also documented here. So check out the readme file. I have specifically mentioned which Docker file did we use in my previous tutorial, how to run it, what is the output to be expected, so that when you all run it, you can actually compare and be sure, okay, it works. And in case you have any questions, please put it in the comments and I will make sure I address them. All right. So in the readme, I have also mentioned all the important Docker CLIs and we'll run through them. Okay, let's get started without further ado. So very first that we will try is Docker pull and then image and tag. So let's try to pull one image. I just say hello world. That's it. Okay. And at this point, it wants to access data from other apps. I'll say yes, please do. Now, what is it doing with this pull instruction? So pull basically pulls images or downloads images from the configured Docker registry. In our first tutorial, in our second tutorial, I have mentioned this in between, that by default, if you do not configure any registry, Docker will consider Docker Hub to be the default repository or the registry for my images. That's what it's doing right now. It is pulling Hello World image from Docker Hub. So default tag was latest because I did not specify anything. An image is now available from Docker.io, which is the Docker Hub, okay? At this point, if I do Docker images, it gives me all the images which currently I have running, which are many, because hey, I'm doing Docker 101. I have a lot of images running, not running, because running image becomes a container. That's incorrect. I have a lot of images available in my system because I'm doing a Docker 101, correct? So I do have a Docker Hello World available with me. And what did Docker pull allow me to do? It allowed me to download any image as I specify from Docker Hub or the configured registry. Like I said, since we have not configured anything explicitly, by default, Docker.io, Docker Hub becomes the registered registry. Okay, so that's Docker pull. Next, let's build the image. Now, this we have executed a couple of times in our past tutorials. Docker build allows me to build an image, right? -t helps me give a name and a tag to the image. So at this point, let me try and build an image for Docker CMD Docker file over here. So I would say, because it's Docker CMD, I have to specify the -f instruction because the Docker file naming is not the standard. So Docker file underscore CMD hyphen T, I would say CLI demo 2, okay, 3 colon V3 dot. What it is doing, it's building my image. We have executed this CLI, but because we are following all the commands, in terms of executing them, we'll execute this as well. So at this point, my execution is complete. And now if I do Docker images, I do have a CLI demo 3 image created just 4 seconds ago for me. Okay, cool. Next, what we will do is list those images. See, we are doing one execution already. To list your images, you do Docker images, or you could also do Docker image ls. Both works. Okay. Next is to remove an image. See, now I have so many images, right? I want to remove them, the ones that I don't need. I have many images in copy also. Like I have demo CLI, I have demo CLI 2, and now I have CLI demo 3. So I want to remove demo CLI. So I would say Docker RMI demo CLI and then the tag, which is V1. It is untagged. Now if I say Docker images, see, demo CLI is not in my list anymore. It is removed. So RMI helps me remove an image. What is Docker tag? It creates a new tag for a local image, which is typically copying your image again. So now I have removed demo CLI. Let me create that again. But I'm not going to use Docker build this time because I already have an image for this. So I would use that image to create another. So I would say Docker tag source. So source would be CLI demo 3 colon V3. And I wanted to say create demo CLI colon V1. All right, it's executed at this point. When I do Docker images, I see I do have demo CLI V1 created a minute ago. And it is exactly the same timestamp created because it has tagged to that same image. It did not create seconds ago. That's why I said it creates a new tag for your image. It has not created a new image. It is your image in another tag format. So you've basically versioned your image. But since it's not a brand new creation, the created metadata is also copied in, right? Interesting. All right, we did Docker pull. Let's do a Docker push. Docker push will do a push of your image to the configured registry. So Docker push, let's push this only, demo CLI colon V1. It is referring to the repository Docker IO by default. It is waiting, it is waiting, it is waiting, and then it gives me an error. So this was expected. Why did this happen? Because, hey, by default, Docker IO is a public repository. It will allow you to download and pull public images by default, even if you have not registered on that registry, which we did, right? We did not register, but we were able to download or pull an image, open public image from the registry. But if I want to push an image or if I want to say download a specific private image, I have to be registered to the registry, which I am not right now. Hence, I get a push access denied. So it is expected. We will work in depth on Docker IO or any repository in our subsequent sessions. But for now, let's understand the importance of the CLI. Docker push will help me push my image to the configured registry. All right. Now let's run into containers. Docker run, we have executed. We know what it does. It launches your container. So let's launch Docker run. I say demo CLI colon V1. It has executed. Okay, it has launched, but why did I not see a response? Remember, what does Docker file underscore CMD do? Right? It just opens up your work directory and default bin bash is executed. But because I did not attach the container terminal to my host terminal using -it, I don't see anything here. There it had worked, right? So at this point, if I want to list my containers, it is done with Docker PS. We will also reach this command. You would see that there is one which is up and I say Docker PS -a, you see there is one which is exited 37 seconds ago. So the container indeed got launched, right? But it exited. Why? Because it did the work and it is saying, fine, I'm done. Why it did so? One, we didn't see it in our current terminal because we didn't attach container terminal to host terminal. And second, we didn't specifically instruct the container to be up and running, to be a live running container. We told the container to perform an action, and as per the way it is configured, it performs and it exits. So if I want this to remain up and running, I have to explicitly make sure that happens. How we will do that? We will see. For now, you understood what is Docker, and we have used these commands like multiple times. It builds or launches. It launches your container. Okay. And we ran all these two again. Docker PS will list all the running containers. That's why I'll clear my screen and we will run that command again. When I did Docker PS, I only see one running container because it only lists you running container. These are running processes within the Docker ecosystem. So it's only one, cranky Faraday, right? But if I want to see all, I do -8. It even lists the ones which are exited, which was the one we created some time ago, right? Next, what are Docker logs? What does Docker logs helps me to do? It fetches and follow the logs of a container, right? So right now, if I want to see my running container, I have this one which is running, correct? So I will try and see the logs of it. I would say Docker logs. What else did it say? -F. And then I give a container ID. Like I said, either container ID or container name would do. And there you go. I see the logs of the container. So Docker logs helps me see the logs of a container. How about I want to inspect a container? So I would use the same container, brilliant typo, and I run the inspect. So inspect basically gives me all of the metadata personality of my container. You see everything about your container over here. It is on ARM64. It has OS of Linux. What are the network settings? What are the mounts? What are the other things? So many things, right? Everything, ID created path. So basically you see the entire personality of your container in the metadata format using inspect. Now, these are interesting instructions: start, stop, and restart. Start. So when you do Docker run, right, there are actually multiple CLIs or commands or instructions or requests going to the Docker daemon. One is to create the container. Second is to then launch the container and then start the container also. Correct? So when you say Docker run, it actually is a split of two CLIs: Docker container create and Docker container start. But we normally, traditionally, mostly use Docker run, but these commands also exist and hence we'll try them out. So oh, I'm so sorry, I made some changes in my README. I don't want to do that. So let me clear the terminal. So we'll run them start in sequence. So I have Docker PS-A. Again, we will see the list of containers. So we have one in started exited state and the other one is up. So let's start the exited container. Okay, see the status now, exited 8 minutes ago. So when I say Docker start, it will start one or more stopped containers. Okay, something happened. Now do you see the exited state? It has changed to 2 seconds ago because it started, and because the way we have constructed the whole Docker file, the launch container does the action and exits, correct? But it did start. So you can see that difference in the status. Restart will first stop and then it will start the container. So you may not see that difference immediately, in front of your screen and as the output, because this is a background activity which happens. So even if the container is in started state, it will stop it and then we'll start it. So we can try this with the running container. Let's do that. Docker restart, and then I give the ID of the running container. Something it is doing, correct? We wait for it. We wait some more. And we are waiting still. Yes. See, at this point, it is up 2 seconds ago. It was up 24 hours ago. Now it's 2 seconds ago up. So in the background, it actually stopped the container and then it launched the container. All right. And stop will stop the container. So I can say Docker stop and the same ID. I'm stopping a running container. The status of up should change because I'm stopping my container now. Let's wait. Yes. You see, it's now exited because I stopped it. Now let me start it again. Yeah, it's up 2 seconds ago. All right, so we did start, stop, restart. Docker RM will remove the container. So if I say Docker RM, let's remove the one which is exited, copy. Okay, now if I do Docker ps-a, I only see one cranky Faraday up and running because I've removed the container with Docker RM. Container stats will give you resource usage of running container. Right now, I only have one container running, and this attaches to your terminal. So we will open up another terminal and run this. Okay. I would say Docker stats, and I want to copy the ID of my running container and give this to the stats instruction. See, it gives me the statistics. So for cranky Faraday, the CPU, memory usage, memory percentage, all those informations are available with Docker statistics or Docker stats. We did Docker exec. What it does, it executes a command like bin bash inside of a running container. So we'll try this now. So I will start my terminal because I kind of closed everything. Okay, here it is. I don't use a command. So I will say Docker exec. I attach it to my host terminal. I give the same container ID and then I want it to run echo hello. Hello. Okay, I did not end the double quote, my bad. And here it is. So I see my Docker hello response. Next up is prune. So what does prune do? It basically removes all unused containers, network, dangling images, and the cache. For that, I have to make sure I do have some images which are not running so that we see the response, right? So let's run the image. So Docker run, I would say demo CLI v1. Correct. Now, if I do Docker ps-a, I do have two containers. One is in running state, the other one has exited. Now I will run Docker system prune. And it gives me a warning because it's a destructive CLI, right? It gives me a warning that, hey, do you really, really want to remove all stopped containers, networks which are not used, any dangling images, or any unused cache? I say, yes, please go ahead and do that. So it has done something. I have saved, right? Or rather reclaimed some 16 KB of space. Now, if I do ps-a, see, I only have one container which is in the running state. So prune has removed the dangling. So dangling will be a very common terminology you would see in the Docker language. It refers to anything which is lying there without any running usage, like for instance the stopped exited containers, any image which is not being referenced, etc. Okay, so dangling would be used a lot. Keep that in mind. Docker container prune will remove all stopped containers. Now we already pruned every object. Since I want to do it again, let me create a container once again. Now if I say I have a list 2 again, I say Docker container prune. Again, I get the warning. I say yes. Now when I say I again only have one. All right. So there you go. We have executed all the common CLIs from the Docker CLI uh, information or from the Docker CLI setup. These are the common ones, the key ones which you will use time and again. Please go ahead and try them all. This repository, like I said, would be available. It's a public repository. I'll link it to the description as well. And with that, we conclude our tutorial number 3. I hope this was a useful one. Next, what we will try and do is we will try and actually push our image to the Docker Hub. We will pull the image and we will also talk about Docker volumes and persistent storage. All right. Please let me know how did you find this session? What are your thoughts, any inputs, anything that you want me to specifically cover? Anything that can, aid us to learn better and then be better. Take care, everyone, and I'll see you guys in the next session. Bye bye.